Hello, I'm going to go through the integration paper you just did, and this is my first time seeing it, so I'm just going to bring you along for the ride. Okay, so question 1, part A is find the integral of 2e to the 3x plus 3 over x squared dx. Well, integrating the e is just normal, but we need to convert the 3 over x squared into 3 times x to the negative 2, so we can work with that negative exponent. So 2e to the 3x plus 3x to the negative 2 dx, and then we can integrate this straight away. So the integral of the e function, you just divide it by the derivative of the exponent. So this is going to be 2e to the 3x over 3, and then the next one you add 1 to the power and then divide by the new power, so it's 3x to the negative 1, and then divide by that new power, so divided by negative 1, and then plus c. Well, you can simplify your answer a little bit, so 2e to the 3x over 3 minus 3 over x, and then plus c. That's it. Okay, next part. Part B, find the area of the enclosed function y equals 0.5 sine of pi over 4 x plus 3, and the x-axis and the line x equals 6. So what this kind of looks like is, if you were to graph this, right, they want you to find the area between 6 and 0, essentially, between the y-axis and the line x equals 6. So wherever x is, sorry, this has been shifted upwards by 3. So I think it should look like that. It should go from here, that is 6, into here, between the y-axis. So they want all of this area over here. So from 0 to 6. Okay, so this is the area equals the definite integral from 0 to 6 of 0.5 sine of pi x over 4, and then plus 3 dx. The integral of the sine function will give you negative cosine. So this will give you negative 0.5 cosine of pi x over 4. You have to use the reverse chain rule. You have to divide it by the derivative of the inside function, which is just pi over 4, and then plus 3x, and this is from 0 to 6. So then just substituting in x equals 6 and x equals 0. For the first part, it is negative 0.5 cosine of 6 pi over 4, simplifies down to 3 pi over 2. And then divide that by pi over 4. And then plus 3 times 6, which is 18. And then minusing when x equals 0, so negative 0.5 cosine of, well, 0. And then divided by pi over 4, and then plus 0. So then just put this in your calculator. So this gives me, okay, so negative 0.5 cosine of 3 pi over 2, and then divide this by pi over 4, and then plus 18, and then this is a minus and a minus, so that becomes positive, so it'll be plussing 0.5, and then cosine of 0 is just 1, so you can leave that as 1, and then divide that by pi over 4. And then I get my answer of 18.64. Okay, I think that should be okay. Next part, part C, find the integral of, so this is the integral of between 2 to 8 of 6x minus 5 over 2x plus 1 dx. So you have two linear functions on top of each other. So you need to separate out into the form a plus b over x plus c, something like this. So then you can integrate this part just by using like a normal constant rule, and then this using the ln function. So you want to separate this out into, so 2 to 8. You're going to divide the top function by 2x plus 1, and then you'll have a remainder. So you can take out, you have a 2x here compared to a 6x. So in order to do that, you need 3 lots of the 2x plus 1s. Those 3 lots of the 2x plus 1. And when you expand that out, you get 6x, which is what you want and what is used to be there. But then you have plus 3, but initially it was minus 5. So how do you get from 3 to minus 5? Well, you minus 8. So all of that is still the same value, but rewriting it, so we can separate this fraction out into 2a, so 3 times 2x plus 1 over 2x plus 1 minus 8 over 2x plus 1 dx. And then these 2x plus 1s, they cancel each other out. So this is the integral from 2 to 8 of 3 minus 8 over 2x plus 1 dx, which then integrates to 3x minus 8 ln of 2x plus 1. But then reverse chain rule, you have to divide it by the derivative of the inside. You have to divide this by 2, from 2 to 8. And so this 8 and the 2 reduce down to just 4 over there. So then you can substitute in your values. So this is 3 times a is going to be 24 minus 4 ln of 2 times 8, 16 plus 1, 17. And then minusing 3 times 2 is going to be 6, and then minus 4 ln of 5. So let's just put that in our calculator. So 24 minus 4 ln of 17, and then minus bracket 6 minus 4 ln of 5. That gives me 13.10. Okay. Next part is part D. So consider the function y equals 3 minus 12 over x. Calculate the total area of the shaded regions. So the shaded regions is going to be, so it goes like this, and they want this area here. I should probably draw it out better. From here, which is 2 to 4, and then again from 4 to 8. So bearing in mind this area over here is going to be negative, and this area here is going to be positive. So you just separate out this area into 2 different integrals. So the area is going to be equal to, so overall it is the integral from 2 to 8 of this function 3 minus 12 over x dx. But because the first one is going to be negative, we need to take the absolute value of the first area from 2 to 4. So this is between 2 to 4 of 3 minus 12 over x dx. And we want the absolute value of that. We just want the positive result. And then we're adding on the area between 4 to 8 of 3 minus 12 over x dx. So this is, the integral becomes 3x and then minus 12 ln of x between 2 to 4. And then this is the same, 3x minus 12 ln of x, but this time from 4 to 8. So the first part we have 12 minus 12 ln of 4 minus 6 minus 12 ln of 2, and then adding on 3 times 8 is 24 minus 12 ln of 8, and then minus 3 times 4 is 12 minus 12 ln of 4. Okay, so let's compute the first part. The first integral gives us 12 minus 12 ln of 4, and then minus 6 minus 12 ln of 2. That gives us negative 2.32. And the second part gives us 24 minus 12 ln of 8 minus bracket 12 minus 12 ln of 4. And that gives us 3.68. So then adding these two together is just 2.32 plus 3.68, which gives us 6. And that's that. Okay, part E. A hot fruit pie is brought out of an oven and put on a rack to cool down in a room where the temperature was 22 degrees Celsius. Okay, so this is, we all know, this is going to be a Newton's law of cooling question. So we want to take down the surrounding temperature as 22 degrees Celsius. 5 minutes after the pie was removed, so when T was equal to 5, the baking thermometer was used to find that the temperature was 80 degrees Celsius. So the temperature at that point is 80 degrees Celsius. After another 15 minutes, so after 15 minutes, which means when T is equal to 20, the temperature had dropped down to 60. The pie will be served when the temperature of the pie is down to 50 degrees Celsius. Okay, so when the temperature is edible at 50 degrees Celsius. And we want to know at what time does this occur at. And we've been told that the rate of the temperature of the pie changes at any instant of time is proportional. So the difference between the temperature of the pie and the temperature of the room, which is the dt over dt, is equal to k times the temperature of the pie minus the temperature of the surroundings. So we need to solve this differential equation using the information that we've been given to us. And we know that temperature of the surroundings is 22. So just separating out your variables, so k times t minus 22 over there. So you're going to divide both sides by t minus 22. But then at the same time, you're going to multiply both sides by dt, d little t, to separate out here. So you're left with 1 over t minus 22 d temperature is equal to k d time. And you're going to integrate both sides, and you get ln of t minus 22 is equal to kt plus c. And at the very end, we're interested in solving for the time. So we're just going to leave it in this form and not convert it into a, we're not going to convert it into an exponential form. So we have these two pieces of information here. So let's plug those in. So the first point that we've been given is when time is equal to 5 and then the temperature is equal to 80 degrees. So ln of 80 minus 22 is equal to 5k plus c. Okay, so then this is ln of 80 minus 22 is going to be 58 equals 5k plus c. Okay, so we got two unknowns there. So we need to use our second point. When t is equal to 20, the temperature is equal to 60 degrees. And so ln of 60 minus 22 equals to now 20k plus c. So this is ln of 38 equals 20k plus c. And with this information, we can then kind of solve for k here. So you have two sets of equations here, that 5k plus c equals ln of 58. And the other equation, 20k plus c equals to ln of 38. So you can see that if you take the difference between these two equations, i.e. the first one and second one, you take the second one minus the first one, you'll get 15k is equal to ln of 38 minus ln of 58, which is just ln of 38 over 58. And then to solve for k, you divide both sides by 15, and you'll get k as a value of, so ln of 38 divided by 58, and then divide that result by 15, gives you negative 0.0282. So then once you have your k value, you can then solve for your c value. So this is using, let's say we use the first equation, 5 times negative 0.0282 plus c is equal to ln of 58. So then c is equal to ln of 58 plus, because this one over here was a minus, so when you move it to the other side, it becomes positive. Plus 5 times 0.0282. And what c value does that give you? So ln of 58 plus that. Oh. That gives me 4.201. Okay, now that I've got this, sorry, I'm just going to go into the next page. So I know that now my general equation is now ln of t minus 22 is equal to k, which we found was negative 0.0282 t, and then plus c, which is plus 4.201. And then we're interested in what time occurs when the temperature equals to 50 degrees Celsius. So ln of 50 minus 22 equals negative 0.0282 t plus 4.201. Solving for t, I get t is equal to ln of 50 minus 22 is just 28. And then, well, I bring the 4.201 to the other side. So I have minus 4.201. And then dividing both sides by negative 0.0282. And I get, so ln 28 minus that, and then divided by negative 0.0282. That gives me 30.8 minutes. That's my answer.